Howdy folks. So now we're going to start getting into some more applications of 4.2, and first thing I'm going to do is just do a little minor correction because this is actually going to be number 2. We've already did example number 1 on the previous page, so let's just do that quick modification. So this is number 2 and number 3 now. Alright, so find the 6 trigonometric function values for the given value of x, y. So we have 4/5 and 5/3, or excuse me, 3/5. We'll get this right. Now, what do we remember from before? If we have an ordered pair, you have the x and the y value. X corresponds to, and y corresponds to. So immediately you should write those two down. So the cosine of our angle, we don't know what it is. Let's use t as our angle. So cosine of t is the x, so 4/5. Sine of our angle is the y, so 3/5. So that's nice and quick. The next part, remember, we have to use x and y to get those other trig functions. So the next one, remember, was tangent. So tangent of t was equal to y over x. So y over x. So let's put 3/5 over 4/5. And if we multiply top and bottom by 5, that should give us 3/4. All right. And now we want the secant of t. And remember that was 1 over x. So that's going to be 1 over 4/5, which we know is just the reciprocal. So 5/4. And then so cosecant should be equal to 1 over y. So 1 over 3/5, which should be 5/3. There's that 5/3 I mentioned. And then last but not least, the cotangent. Cotangent of t should be x over y. So again, we're just taking the reciprocal. So this is just going to be 4 over 3. And we're done. So anytime they give you the ordered pair that's on that unit circle, it has to be on the unit circle. This one didn't specifically state it, but it's implied for this section. So that is on the unit circle. So we should be good to find all of our 6 trigonometric functions this way. So now the next one says to evaluate the 6 trigonometric functions at the real numbers. So now they're not giving us the ordered pair, but they are giving us the angle. So how do we proceed with this one? Well, there's not really a easy way to get x and y from this, but we do have a cheat. Remember, if we go back to the previous page, we have this unit circle with all this lovely information on it. And so we can quickly see that 2 pi over 3 is 120 degrees. And there's our ordered pair. So negative 1/2, comma, positive square root of 3 over 2. And so that is the information we need. So we can immediately point to negative 1/2 positive square root of 3 over 2. And now we're on our way. So let's do the same thing as before. So we got the cosine of t, well, which we know what t is in this case, so I might as well put the angle in there. 2 pi over 3 is equal to negative 1/2. Sine of 2 pi over 3 should be equal to square root of 3 over 2. Tangent. So y over x, so square root of 3 over 2 over negative 1/2. And again, if we multiply the top and bottom by 2, So that's going to give us a negative square root of 3 over 1. So negative square root of 3. All right, let's get our secant. So 1 over that, or just the reciprocal of that, so negative 2 cosecant of 2 pi over 3. So again, we're going to flip that over. So 2 over square root of 3. Now, I am not 100% sure how WebAssign is going to behave with an answer like this. They might not like the square root in the bottom of the fraction. So we do have to rationalize that potentially. So remember, you just multiply the top and bottom by the square root of 3. And so that's going to give you 2 square root of 3 over 3. And then last but not least, our tangent will help us get our cotangent of 2 pi over 3. So we need to do the reciprocal of that. So 1 over square root of 3, don't forget the negative. And same thing as the previous one. Multiply the top and bottom by square root of 3. So that should give us negative square root of 3 over 3. All right, so there is a couple of applications. And again, that unit circle, really important for some of these problems. It'll help you get to those answers a lot quicker if you have that memorized, or at least have quick access to it. So, okay, let's stop there and we'll pick up some more applications. You can see we got domain and period of sine and cosine coming up next. So stay tuned for that.